Hi, Assalamualaikum. My name is AINAA SOLEHAH. For today, I want to discuss about PRE-PSPM question 1 of KMNS 2022-2023. Question 1A. Table 1 shows information about isotope in a sample of silicon. Okay. The question is, by using the information, calculate the relative atomic mass. Before we calculate relative atomic mass, we have to determine average atomic mass first. This is the formula of average atomic mass. We simply say it KMPK because this was actually the easiest way to memorize the formula. So just simply say KMPK. Okay. Q, we sub percentage abundance. This one is for Q. Okay. M, we sub number of proton plus with number of neutron. And then we get 28, 29 and 30. And then we will get the final answer 28.11 AMU. This one, you will get 1 mark. Answer with unit 1 mark. Next, there was only average atomic mass, but the question 1 relative atomic mass. Average atomic mass, we determine here 28.11 AMU, and then mass of carbon is 12 AMU, and then the final answer we will get 28.11 without unit, and then this one you will get 1 mark. Final answer 1 mark. Next question. Question B. Sodium bicarbonate react with citric acid. Given 1 gram of sodium bicarbonate and 1 gram of citric acid. Determine the limiting reactant. There are 3 simple steps to determine limiting reactant. Okay, so this is the step. First one is find mole given. Given 1 gram of sodium bicarbonate and 1 gram of citric acid, right? 1 gram, we can convert to mole. Okay, then we can get mole given. Mass over molar mass. This one also mass over molar mass. And then you will get mole given. So the first step is done. Second step, stoichiometry. From equation, 3 mole of sodium bicarbonate equal to 1 mole of citric acid. Just substitute the mole given in the equation. 3 here, bring it here, and then you will get over 3. 1 here, just multiply it. You will get mole needed of citric acid. So second step is done. Last step is compare mole needed and mole given. Mole given of citric acid is more than mole needed. So given mole needed, we know that that was excess. So the limiting reactant is not citric acid. So we conclude that sodium bicarbonate is the limiting reactant. Okay. Next question. Calculate the mass of carbon dioxide formed. Carbon dioxide is on the product, not reactant. So to determine the mass, we have to do stoichiometry with limiting reactant. Limiting reactant, just now we determined that sodium bicarbonate. So 3 mole of sodium bicarbonate equal to 3 mole of carbon dioxide. And then you will get mole of sodium bicarbonate is equal to mole of carbon dioxide. And then the question asks for mass. So the formula of mass is mole times with molar mass. And then you will get the final answer. This one, final answer 1 mark. For chemistry, 1 mark. Next question. How much of the excess reactant remain in gram after the reaction is complete? We know that excess reactant we determined just now is citric acid. Okay, so the question asks for remain in gram after the reaction is complete. Okay, we know that the formula for this question is mole given minus with mole needed. Also, we determined just now, we know that mole given is 5.21 times 10 to the power of negative 3, and then mole needed 3.97 times 10 to the power of negative 3, and then you will get the mole remain 1 mark. Okay, but the question asks for grams, which means question 1 in mass. Okay, the formula for mass is mole times with molar mass. The molar mass is given in the question here, so just sub it 192. You will get final answer 1 mark or so. Next, question C. Calculate the mass of HCl contained in 500 ml of a solution if the density of solution containing 37.2% of HCl by mass is 1.19 gram per ml. Alright, so given density and also percentage by mass. Density, the formula is mass of solution in gram divided by volume of solution in ml, density. And then we know that the question said the density is 1.19, so just sub in the formula. And then the question also gives us volume of solution. Okay, so we can determine the mass solution. This one you will get 1 mark. The question gives us percentage by mass, which is 37.2%. Also, we can sub the mass solution in here. Okay, and then you will get the mass of solute, which is solute is HCl. Solute, mass of solute. This one also you will get 1 mark. This one 1 mark. Answer 1 mark. This one either 1 mark, and final answer you will get 1 mark. Last question. D. In an experiment to displace copper from copper 2 sulfate, 6.5 gram of zinc was added to an excess of copper 2 sulfate solution. Okay, the mass of copper obtained was 4.8 gram. The first question asks for write a balanced chemical equation for the above reaction. Okay, the first element that we determined just now is zinc. So zinc is in solid, and then we know that copper sulfate. Okay, and then you will get product zinc sulfate and copper, and this one you will get 1 mark. Next question, calculate the percentage yield of copper. The question asks for percentage yield of copper. We know that the question given 4.5 gram. This one is actual yield. Okay, so we want to know what is the theoretical yield of copper. When we want to determine for percentage yield, it was actually related with limiting reactant. Okay, what I said just now, limiting reactant, we have 3 simple ways, right? 3 simple steps. Okay, this one, let me copy first. The first step is find mole given. We know that zinc is limiting reactant. Why? Because the question just stated that 6.5 gram of zinc was added to an excess of copper. Excess of copper. Let us use this formula. Find mole given. Mole given of what? Mole given of zinc, because zinc is the limiting reactant. Okay. Given mass of zinc, so we can determine the mole of zinc. Second step, stoichiometry. 1 mole of zinc equal to 1 mole of copper. Make sure this one is limiting reactant. This one is what we want to determine. So we can conclude that the mole of zinc is equal to mole of copper. Okay, and then we want to search for theoretical yield, which is mass in gram. So that's why we times with the molar mass of copper, and we will get 6.3 to 1 gram of copper. This one is theoretical. Write the formula of percentage yield, which is actual yield over theoretical yield times 100%, and then sub, and you will get your final answer, 1 mark. Okay, this one is 1 mark, this one is 1 mark, final answer 1 mark, and you will get 3 marks here. Thank you for watching, and don't forget to subscribe to the PAL Kimia KMPK channel for more chemistry solutions and tips. Thank you.